All right, I just wanted to hop on here and walk through some of the more complicated questions in homework 3. So these first ones, I posted solutions, but the main questions I wanted to walk through are a little bit later. So let's do question 3. So this question is about preferences for two different types of drinks, and we have two different subgroups of the population. So the way we can represent this is with a probability grid, just like we typically do. And if you prefer using other tools, that's totally okay too. The probability grid is just the way I find to be easiest to sort of conceptualize these types of questions. So we're given some information here, and when I'm given a statement like this, I like to write it out in probability notation. So that's where I'm going to start. So the first thing to do, so we're saying 30% said they preferred soda. So the probability of soda is equal to 0.3. And then we said 60% of the patrons were not female. So this is 60 are not female. So this is 0.6, which, the complement of that is the probability of female is 40%, so 0.4. And then we can also write out the probability of not preferring soda, which is water. So the probability of water is equal to the complement. So this is 0.7. Okay, so nice. So we have all of these things written out. And then the last one is 20% of the patrons were female who preferred water. So this is the joint probability. So this is the probability of female and water. So this is these two things together at the same time. And this thing is 0.2. Okay, so we're asked to use a probability grid or table to guide your answer. So in this case, I prefer using probability grids. So the first thing I like to do is just set up the probability grid. This is going to be useful not just for potentially this first question, but also for the second one. It's going to turn out it's not going to be that useful for the first one. So maybe on the vertical, we'll have the probability of female, and then we'll do, this is 0.4, and then we have the probability of not female is equal to 0.6. Okay, and then we're given some other information, and we can just try to fill this stuff in. So the probability of female and water is 0.2. So it's the joint probability, so the area of one of these things is 0.2. So because this is 0.4, we can actually just split this. So the area of female and water plus the area of probability of female and water plus the probability of female and soda is equal to 0.2. It's just the probability of both of each of the things happening, and we just add them up together. Okay. Excuse me, this should be 0.4. So both possible states of the other condition. Okay, so then we know if this thing is 0.2, then the complement is 0.2 as well. So the probability, so this area is 0.2, and then this area is 0.2. All right, and then we'll fill this in maybe a little bit later. Okay, so the first part of the question is, based on the information above, what's the probability that a randomly selected patron prefers water? Well, this, we actually don't need the probability grid. We just need the complement. So we say 30% prefer soda. That means everyone else must prefer the other thing. So that, in this case, is this. So the probability of water is 0.7. All right. So based on the information above, what's the probability that a randomly selected patron prefers soda and is not female? So this, just writing this out in probability notation, we have the probability of soda and the probability of not female. So if we were to set up the question in terms of the probability grid, we're looking for the probability, so this is probability of female and soda is this thing, and then this is the probability of female and water is this thing. So we're going to look at the probability of not female and soda, which is, we're going to draw a dashed line here. So this is, we'll have A and we'll have B. This question is the area B. So we're going to try to find what B is using the information we're given. Okay, so let's rewrite this thing. We know, so on the side here, I'm going to write, so the probability of soda is equal to this area, so the probability of female and soda, plus the probability of not female and soda. So this is the probability of female and soda, plus the probability of not female and soda. Well, we know what two of these three things are. So the probability of soda we're given here is 0.3. The probability of female in soda is 0.2. And then the last bit is the probability of not female in soda, which is B. Okay, so all we have to do is solve for B, and then we're done. So here we have B is equal to 0.3 minus 0.2, and that comes out to be 0.1. Okay, very nice. So let's maybe skip 4, and we'll go to question, well, let's skip 5 as well. And let's go to question 6. All right, so here we're given, this is sort of a medical type question. We're given 2 different types of cancer and 2 different survival rates. So let's just write out some of the things we know from this statement in probability notation. So the first thing, probability of A, and I'm just going to cross this out so we don't get confused what we're talking about. Okay, so the probability of A is 1/3. So that means the probability of B is 2/3. Okay, so then we're told conditional probabilities here. So 4 out of the 5 patients diagnosed with type A die from it within a year. So the probability of death given, it's a very grim question. So the probability of death given A is equal to 4 out of 5. So 4 out of 5. And then the probability of death given B is death given B is equal to 1/5. Okay, so we're going to set up our probability grid and then try to solve this thing. So we'll do it over here. So the probability of A is 1/3. So we have 1/3 probability of A. Then the probability of B is the complement, which is 2/3. And then on the for our conditional probabilities, we have the probability of death given A is this thing. Probability of death given A is 4/5. And then we have the complement, so that'd be 1/5, but I'm not going to write it in. And then the probability of death given B is 1/5. So this is the probability of death given B, and that's equal to 1/5. Okay, nice. So I'm going to shade in these two areas just to represent that this is the bad, bad state of the world. Okay, so what's the probability that your patient has type A cancer and successfully survives it? Well, that's this area. So we're looking for the joint probability here. So it's probability of A and survives it. So this is not death. Okay, so this, we have our standard conditional probability definition, which is, or one of the ways we can define it, which is the probability of A given, actually, let's write this a different way. This is the probability of not death given A is equal to the probability of not death and A over the probability of A. And we know two of these things. So we know the probability of A and the probability of not death given A. So we can multiply both sides of this relationship by the probability of A. So that tells us, and you may already have this as a definition. I usually like to refer to this when I'm constructing this joint probability. But you can also see it from just our probability grid. So we have the probability of this joint probability is the product of the probability of A times the probability of the conditional. So this is probability of not death given A. Okay, so nice. So we know the first thing is 1/3 probability of A. Then we multiply it by the second one, which is 1/5. And this comes out to be 1/15. Nice. So what's the second question? So this is, what's the probability that your patient dies within a year? So this is really just the probability of D. Okay. So the way I've drawn this probability grid, all we're looking for is the area of this shaded region. So just like we did above, we're looking for the sum of the two joint probabilities. So this is the probability of A times the probability of D given A plus the probability of B times the probability of D given B. Okay, and then we know all these numbers. So the first one, we have 1/3 times this, which is 4/5, plus probability of B is 2/3 times this thing, which is 1/5. So this is 4/15 plus 2/15. So this comes out to be 6/15, which we can simplify down to divide top and bottom by 3. So we get 2/5. Nice. So the last question for 6 is, suppose your patient dies in less than 1 year, before you learn the exact type of cancer. Given the SAD happening, what's the probability? Gender mismatch here. They had a type A cancer. So this is, what's the probability of A given D? Okay, so again, we can rewrite this thing in terms of joint and marginal probabilities. So this is the probability of A given D is equal to the joint probability. So this is A and D over the probability of D. Okay, so we know this one. We calculated the sort of complement of it up here. But we're going to rewrite this. And then the bottom one is what we just calculated in part B. Okay, so on top, we have the probability of A. So we can rewrite this as the probability of A times the probability of D given A. So just essentially using this identity again. And then on bottom, this is just the probability of D, which is a thing we've already calculated. So the probability of A is just 1/3. 1/3 times probability of D given A, which is here, 4/5. And then on bottom, we had 2/5. And then we'll just multiply these things together. So this is 4/15. And then on bottom, this is equal to 6/15. So this is 4/6, which is equal to 2/3. Nice. All right, so let's do question 7. So here we have a sad state of me drinking coffee in my office alone. Okay, so let's figure out some information about this. Interesting enough, there's no mention of students drinking coffee in my office with me. Maybe this whole homework assignment is just a cry for help. Okay, so let's just set up first off the information we know, and then we will work through how to solve for the questions. Okay, so I'm gonna move down. So the probability. So let's just write the probabilities we know. So the probability that Catherine drinks tea with Taylor is 1/4. So this is probability of K is 1/4. Probability of not K is equal to 3/4. We have the probability of Jane is equal to 3/8. So this is 3/8. And then the probability of not Jane is equal to 5/8. Okay, and then the probability that neither thing happens is 1/2. So the probability of not Catherine and not Jane is 1/2. Okay, so let's first set up the probability grid, and then we can think through how to answer the questions. So the way I've set this up, I'm going to have the probabilities for Catherine on the vertical axis. So this is 1/4 probability of Catherine, and then probability of not Catherine is equal to 3/4. Okay, and then we don't know where these lines are, but we know that A plus, oops, I can't do the alphabet, A, B, C, D. So the probability of Jane is equal to A plus B. Nope, still can't do the alphabet. Plus C. Okay, so we'll come back to this and work through these things. Let's just first set up the first question. What's the probability that Taylor has tea with Jane while Catherine's not there? So this is the probability of Jane and not Catherine. All right, so just for the statement of the question, given the probability grid, this is not Catherine and Jane. So this is equal to C. Okay, so we know for it to enter this here, the probability of not Catherine and not Jane is 1/2. So D is actually equal to 1/2. So when we're setting up this question, all we have to do is reference this number here. And maybe the way we'll do this is by thinking about our probabilities for not Catherine. So we know in total, the probability of not Catherine is 3/4. 1/2 of those times, or 1/2 in total, Jane is not there either. So C, it turns out, so we have C plus D is equal to 3/4. And we know what D is. Well, it's just 1/2. So C plus 1/2 is equal to 3/4. So we can just simplify. So this thing gives us C is equal to 1/4. Okay. Nice. So the next one, we have Catherine did not have tea with Taylor. What's the probability that Jane was not there either? So this is a conditional. We have an if statement. So this is the probability that Jane was not there given that Catherine was not there. So this is not Jane given not Catherine. And this thing, we can just rewrite this in our joint probability notation. So this is, visually this is not Jane given not Catherine. So we're looking at B and D, and we want the probability of B, the probability of D given that we're in B and D. So just to write this out in sort of areas, this is D given B plus D. Okay, so we know a bunch of these things. We know B. Well, I guess we don't know B just yet, but we do know D. So most of what we're going to try to do is calculate B. Okay. So, nope, I wrote this wrong. So this is, we have C and D. So this is a C. So we're looking for, we want not Jane within the subset of all not Catherines. So this is D over all of not Catherines. So we can, if you prefer the probability of not Jane and not Catherine, some people prefer this notation. And then we have not Catherine. This is, one of our probability rules, but we can express it geometrically. Okay, so nice. So on top, we have this area B, this area D, which is 1/2. So let's put on top, we have 1/2, and then on bottom, we have the probability of not Catherine, which is 3/4. And then we can just simplify this. So it turned out to not be a lot of actual work here. So this is 2/4 over 3/4, so that's 2/3. Okay, very nice. So the last part of the question is the probability. So again, this is going to be a conditional probability because we have an if. What's the probability that Catherine did not join given that Jane was there? So the probability of not Catherine given Jane. Okay, so nice. Just visually, what we're trying to do here is we're looking at all of the probabilities for Jane. So this is A plus C, and then we're looking at only the ones where Catherine did not join, which is C. Okay. So we've already found C from question 1, so let's just fill that in. So this is 1/4. And then on bottom, we know these two things must equal the probability of Jane, which is given to us in the question, which is 3/8. So this is 1/4 over 3/8. So that's 2/8 over 3/8. So this is 2/3. All right. I'll see you in the next one.